So here's the story. I was just driving back home and then I was thinking about my quadratic formula. And we know A, B, C here, they have to be constants. But is it possible for us to still use the formula even when A, B, C are not constants? And I'm not talking about A, B, C being functions of another variable such as t or y. No, I want A, B, C to be functions of x. And I thought about it. I don't see why not, but I don't know why nobody ever talks about it, and I wonder if this will give us an advantage to solve like some crazier looking equations. So I decided to just work on paper, and now let me show you guys what I did. So this is my first try. Let me start with this, x plus third power minus 5x, and that's the plus 5x minus 6. So right here we can see x equals 1 is a solution. And we know this right here is a cubic equation. But now check this out. Instead of looking at this as x plus third power, let's look at this as x times x squared. I know you know too. Anyway, plus 5x, and then this right here is minus 6. Here, A, B, C, quadratic equation. So let's use the quadratic formula. Let's take a look. This, by the quadratic formula, it should give us x equals negative b plus or minus square root b squared minus 4ac. A is x and c is negative 6 all over 2 times a, which is x. Yeah, we did end up with another equation, but this equation, unfortunately, is not any easier than the original. And you can just type this into Wolfram Alpha and see if the solutions matches or not. But I will tell you, I was not too satisfied with this, so I decided to just leave it. One reason is because I wanted to somehow utilize this idea to help us simplify the original equation. So I decided to kind of work backwards. So this is what I mean. I start with the quadratic equation. We know we should have negative b plus or minus square root of b squared minus 4ac all over 2a. And that should give us x. So I was thinking about what if I start with the square root part and then I somehow get rid of it. And I want to make the original equation as crazy looking as possible. So I decided to put b to be sine x, with the goal that I want to make the inside sine squared plus cosine squared. Right here, I can put down 1 over 4, but I don't need to. I want to still have a equals 1, so that it's just better if we have 1 in front of the x squared, right? Now, right here, I will just have to get rid of the 4, so I put down 1 over 4. Aha! And this is a negative, so I need to have a negative here and pair that up with cosine x. How is this? B is also sine x, so we put it here. Alright? So that said, we work backwards. This is my second creation. I have this for you guys. A is 1, so it's just x squared. But now b is sine x, so plus sine x times x. And this doesn't really look that nice, so I like to put down the x first. Much better. And then we are going to have c. This is c, yeah? This part right here is c. Negative 1 over 4, so let me just put down minus 1 over 4 cosine square x, and that has to be equal to 0. So if you see this equation, what do? Well, guess what? You can try to do this. I think this is pretty hard if you want to try to solve it by hand, but apply this quadratic formula in this way. This simplifies very nicely. Have a look. X equals, that is negative sine x, plus or minus sine square plus cosine square, which will just get 1, and then over 2. And of course, we can then just multiply 2 on both sides. So in fact, this right here can give us just 2x equals negative sine x plus or minus 1. And then from here, you can solve it. And of course, if you look at this equation, unfortunately, you cannot solve it in a regular sense by doing like algebra work. You will have to utilize some kind of numerical approaches, such as Newton's functions. So I will go over that with you guys real quick. We will have to look at one equation at a time. Let's do the plus first. And we also have to make one side equal to 0. So for the equation, 2x, let's put this to the other side. And also put a plus 1 to the other side. Let's solve this one right here first. We have this is equal to 0, so we can say f of x equals 2x plus sine x minus 1. And then we also need the derivative. The derivative of 2x is just a 2. The derivative of sine x is cosine x. And now, let me remind you guys what the Newton's method is. I have done a video on this, so you guys can go check that out. The link will be in the description. We are doing iterations pretty much. You start with an initial guess, and after that, the next x value will be the previous x value minus the value of the function at that previous x value divided by the derivative at that previous x value. And if you look at this function here, when x is equal to 0, the result is negative 1. And when x is 1, this is 2 already, sine of 1 is positive, and then minus 1, for sure, we get positive. So we know f changes from negative to positive from 0 to 1. That means there must be an answer between 0 and 1, because this is a continuous function. So I'm just going to start with x0, my initial guess to be 0. So this is my pick. After that, x1 equals, put 0 into here, minus the value of the function is 0, and then divided by the derivative there. And I'll tell you this is about 0. It's 1/3, but I will still write it as decimal, like this. And now for x2, this right here is just equal to whatever the x1 is, and then we plug in x1 into the function, and then divided by its derivative. Right, so just work that out. I'll tell you this is 0.335418. And let's just do it one more time.
x3 equals x2 minus f of x2 over f prime of x2.
We pretty much are done, because if you do it again, this right here, they don't change. So for this equation here, in fact, you only have one real solution. You can do more calculus for that, but you end up with this for the answer. Guess what? Originally, this equation also has this for the answer. Okay? In fact, for the original equation, this right here has two solutions. I will write this down. Two solutions. One of them being this, which we solve by considering this right here. And in fact, this equation, remember earlier we do the plus, we should also have done the minus. If you do the minus, it will give you the other solution for this. And in fact, for this equation, I'll just put it down right here. All right? I'll tell you. So just try the other one on your own. X. I just want to create a new technique of solving equations.